Hello and welcome to my Blender to Unity Tower Defense game tutorial, and in this part what we're going to do is we're going to create the machine gun turret logic to capture enemies that come in and out of range, lock onto them and potentially fire at them. So let's get started. So it goes without saying, the first thing we're going to need to do is put our machine gun turret onto the terrain. So let's just pop into our prefabs folder, click on machine gun turret and just drag that in. Okay, obviously, but when we actually do it in the game, we wouldn't just, that wouldn't be hanging about there. We'll create the buttons to click and position it. But for now, we're just doing this as a test. So let's just get it in the right position. One thing I've done, by the way, is I've changed the scale. I don't know if you can see this to 0.75, 0.7, 0.75 on the containing empty. That contains the base of the stand and the machine gun. The one was too big, and I want these to have two. So that would be a one spot. That would be two. That would be two. That's going to be one. So I'm just positioning it, and I've realised already that those corners aren't sharp enough. It kind of doesn't work. But this is a prototype. So that's good. That's in position, and it's going to work for now. And the way I'm going to tackle this issue of enemies coming in and out of scope is I'm going to use a collider. Okay, now normally a collider is used to collide the actual object itself with things like walls or the ground or whatever, but I'm going to use it as a kind of a range feature so that the enemies coming in and out of range will be picked up. So let's add that, and I'm going to add it to the machine gun. And the reason I'm going to add it to the machine gun and not to at the top level, if you like, the folder level, is because I want this script. What it's going to do as well is it's going to rotate the turret to point at the enemy as it sees it. Okay, so let's click on here and let's add a component, and we're going to add a collider, and we want a sphere collider. Now what Unity's done is it's gone, okay, I'll try and get a sphere collider that fits your object, and that's great and everything, but we don't want that. We want it to be actually the range functionality. So what we'll do here is we'll just go over to the radius and set it to 3. I think that looks like a good size to me. Again, I'd imagine when we upgrade these turrets and stuff, that range will get bigger. And if we just drag the Y down so it's nearer the floor, not all the way, just about there is fine. Okay, and we'll also need to click is trigger. Let's do -1. How does that? Is that alright? Does that show up? Yeah, that shows up when you look at it from above. Let's just quickly do that. Click on the Y there, and I've got it in orthographic mode. So here we go. Okay, good. Now, because we've selected this trigger, anything that enters this collider will call a couple of functions, or enters and exits, excuse me. When it enters it, it'll call a function called onTriggerEnter, and when it exits, it'll call a function called onTriggerExit. So let's write that now. Let's go over to our scripts folder and create a new C# script, and of course we call it turret targeting system. And let's just double click that. Okay, there we go, here it is. Now I'm going to ignore the start and updates for now. I'm not going to delete them, I'm going to keep them there just because we'll almost certainly be using them. So the function is void on trigger enter collider and void on trigger exit collider. Okay, that's good. And we'll put a debug in debug.log enemy entered enemy plus game object collider dot game object. So that's the game object that the collider is attached to, in range, and then dropped out of range. Okay, great. And if we go back, save that, and let's make sure we attach it to the machine gun here. Like I say, did I already attach it? I don't know. Hang on. I did not. So let's add it now. Drag it in, attach it to there. It doesn't do anything right now. So let's run it. And you might be thinking, oh, good, this is going to work. And I'm afraid it's not going to work out of the box. Let's just go to the console. Wait for our disks to come in, and we're hoping that it's going to do a debug when it ends. Let's just go to the top view again. Hang on. But it doesn't. A couple of reasons for that is that these guys here don't effectively exist. That's maybe the wrong term, but they don't have any physics to them. There's no actual substance to them, because we need to add what's called a rigid body to them. So let's do that right now. Okay, and I don't know. I'm going to try something here. I'm going to click on both of them, and then do, yeah, look, I think I can do this, and then do add component, rigid body. Okay. The only thing we need to think about here is the fact we don't want to use gravity. If we do use gravity, then these things will drop through, because the terrain doesn't have any rigid body, and so it'll just drop straight through. Okay, so we don't care about gravity in this. We're just using this as a kind of sort of trigger function to use the range feature. So we'll click on play again, and I'm very confident this still won't work. No, nothing's happening. Can you see there's no debug lines? And the final reason for that is that we need to add some colliders to these guys. Okay, so let's do that. So probably the best way to do that, I'm going to drag one in, just drag it in, and then I'm going to add the component to this one, collider, and we'll go for a sphere collider for that. And now we do want it to be the same size. Do you see? Because this is the object that's actually entering it in. It's a little taller. You can't adjust the actual height. This is a cylinder. Excuse me, a sphere. So we don't really care, because it's not going to really matter that much. There are other ones, there's capsule colliders and stuff, but we're going to just go with that for now. So I'm happy with that. So what I'm actually going to do is I'm going to click on apply, and now I can delete that one. And let's bring our alien craft in. By clicking apply, by the way, it adds it to the prefab. Okay, this is curious. It looks as though I've not adjusted the rotation for this, which surprises me. So let's just reset that and apply it. This is where everything's going to go completely wrong on this, and I might have to have a look at that later. But let's add another component. For this one, I might judging by the shape, I might go for capsule collider. Okay, and it's done a sterling job actually of setting the size for that. I'm very pleased with that. Okay, and again we'll click on apply, and we can delete it. Now if we run our scripts, let's go to the top. Okay, there we go. Okay, can you see? So you're going to get a lot of in ranges as these things come in range, and I'd imagine any second now you're going to start seeing them out of range, dropped out of range. Can you see there? There you go. They've actually exited the collider, the sphere collider. Fabulous. And we have ourselves our first problem. Look at that. Oh my word, I love it. They're drifting through. That's brilliant. I think we can fix that very easily by just going to our ones here and clicking on is kinematic. Let's give that a quick go. I'll tell you what I'll do. I'll pause this, and I'll wait till they come through to the other end, and then I'll restart. 1 second. Okay, so my mistake. The issue, of course, is that the rigid body should be on the machine gun turret. Excuse me. The rigid body should be the machine gun turret. Again, making sure that use gravity is off, and we need to remove the rigid body from the alien disc and the alien craft, which I've done. Okay, so remove the rigid bodies from the alien craft and alien disc, and add a rigid body to the machine gun. Okay, that will mean, but keep the sphere colliders on the alien craft, the capsule colliders, excuse me, and the alien disc. Keep the sphere colliders on those. And now, if we run, hopefully we'll be in much better shape. This kinematic thing is completely wrong, by the way. Don't have that checked. I'll just show you now. Okay, it doesn't matter for the machine gun. Okay, just don't have that checked. Okay, here we go, and we can see them that they are coming in range and dropping out of range, and now disappearing off. Okay, they still need the sphere colliders. Great. So all that remains now really is to keep for this well, not all that remains, but the next thing to do is to say, well, this is great, and I can see these objects coming in and out. I've just seen something else. I've reset the size of the alien craft, haven't I? Let's quickly change that back to 0.75 and then apply. No, I don't need to because I'm in the prefab already. There we go. So what we should do is we should say, well, if it comes, we'll have an array of objects that drop in and out. So we should also double check that they are actually aliens. So what we'll do under here, where are we? Tag. There should be. We're going to add a tag. We'll click on tags and we'll just add one called enemy. Right, and now if we spin back to prefabs alien craft, we can tag it as an enemy, and also under alien disk tag this as enemy. Okay, you with me? Good. We're making good progress. Now the reason I've done that is because I want to make absolutely sure that what's entering into the collider is actually the enemy. I'm not saying it would be anything else. It's unlikely, but you know what? It could be. For instance, it could be another turret. Okay, so that's something to think about. Right, so let's go back to our script and take a look at it here. Now, like I said, what I want to do is have an array, effectively, of objects that are enemies that are in scope for shooting at, and ones that are out of scope, or just say out of scope, but you simply can't see them. Okay, so the way I'm thinking of doing this is saying, well, let's have an array of anything that we know is in scope, and then if I kill it, it blows up or it leaves, and I'll have a look to see what else is left in my array, and then I'll shoot at that next. Right, so let's have a look at how we're going to do this. And the way we're going to do this is by creating an object up here called public array list of type game object enemy game objects. Okay, there we go. I thought that I was going to say it wouldn't work, but if we've got system.collections already there, so now we can say tab here enemy game objects equals new array list, and that obviously also has of type game object. Game object, there we go. And what we're going to do down here in the on trigger enter, we're going to say if brackets collider dot game object dot tag equals enemy, and then we'll do debug.log enemy entered range adding to array, and then we'll do enemy dot add. Why isn't it like that? Have I done something wrong? Add collider dot game object. Okay, let's just see. Sometimes it doesn't throw errors here, but you go into Unity and actually show you what the problem is. Here we go. The non-generic type cannot be used. Let's have a read of that. The non-generic type array list cannot be used with the type arguments. So what have I done wrong? So what I've ended up doing is just removing the generic type from array list. I think it's because array list doesn't allow generic types. List does. Okay. So let's give this a go now. Clicking in here. Click here. All compiler errors. Let's just make sure I've not messed up something. Where's the error? Did I not save it? Hang on. There we go, it's fixed. So what I did, guys, was I just removed the generic type. Okay, so it's just an array list now, enemy game object. So let's give it a try. Again, go to console. There we go, enemy entered range adding to array. This is working rather well. So, okay, so let's do on trigger exit. What we can just do, we can say enemy dropped out of range. Oh, we could do the test. We don't need to do the test because what we could just potentially do is just say enemy game objects dot remove collider dot game object. Okay. That may or may not work because if for instance, like I say, if a turret was added, then if it tried to remove it, then it wouldn't be in that array list because we checked before that it was actually an enemy. So it would just kind of fail quietly. But let's put it in just to be consistent. Okay, so let's just do this. Control C, like so. Oh, I don't know. It looks like I forgot you. So let's pop you in there and get rid of that debug. Enemy exit. Enemy went out of range. Range removing from. I suppose technically speaking, it might not just be out of range. It could be because it died or blew up or something, couldn't it? But for now, let's just go with that. Okay, and now if we. It does not contain a definition for add. What is it then? Add, sorry. Apologies. There we go. Okay, let's run this now. Can we see under here our script? Where's it gone? Here it is. No, it's not. It doesn't like array list look in the inspector, which is a bit annoying, but there we go. Okay. And it's adding them, and now it's going to remove them from the array. Alright, so that effectively is our kind of sort of in and out of range script bit complete. Now let's move on to getting it to rotate and sort of at the target that it's the first target that comes into range. Okay, so let's get it to do that right now. Alrighty then, so what I've done is I've made some serious modifications to this script. I was going to go through it line by line, as in type it in line by line, but I thought maybe better if I just did the script and then show it to you. So let's just talk about what I'm going to do here and the way I've implemented this. It's a fairly standard model actually. It's what's called a state machine, if you like, whereby the turret is going to have various states, and I know that a lot of models here would probably use interfaces depending on the different states that it's in, but I'm not going to do that, and there's a reason for that, and that is because I find using interfaces makes it quite disjointed, and some of the variables you have to share between the interface, the implementations of those interfaces makes it very confusing. At least I think it makes it confusing for something that's not necessarily that needs to be so complex when there's only a few states that this turret can have. And here they are. So I've created an enum with those states. Disabled I'm not using right now, but I imagine that perhaps an enemy could fire some sort of freeze or perhaps disable the turret in one way or another. Idle, as the name suggests, means it hasn't got a target. Okay, locking on means that it's found a target and it's rotating towards it. There's some games simply snap the turret straight to the object. I like the idea that it would rotate towards it and then start firing. And indeed, the engaged state is that state. So I've set up a variable to contain that state, which is current target state, and you can see that I have put it into the idle state here. So let's have a little look at the update method now. We've got check. We haven't seen. You notice we're not checking for disabled. Maybe I'll add that and just leave it as a blank state. Why don't I do that now? If brackets current target state equals turret state dot disabled. And I just make sure I put else if here, else if, okay, and then we'll just say here do nothing or something like that, right? Or perhaps we should put to do in there. To do work out disabled logic. Okay, and then we have our different states here. So we've got the idle state, which looks to see if there are any enemies in our array. Which makes sense. Okay, so it's not doing anything. Let's go and just check if anything's come into scope. If it hasn't, do nothing. We'll take a look at that in a second. So if it's locking on, I've created a method called lock on, and if it's engaged, then we're going to look at the target, which basically means don't bother rotating towards it now. You found it, just keep looking at it, and then maybe fire, because we don't want this firing every frame. We may have a little time lapse between that. I haven't done that in this tutorial. I think we'll do that in the next one. Okay, so let's start with the idle state. Check for enemies in range. Okay, let's just slide on down here. Okay, and all this is doing is it's looking at the array to see if anything's gone in there. Okay, saying if there are any that array that gets updated by our on trigger enter and on trigger exit. Okay, then it says, right, okay, if it's greater than 0, oh yeah, there is one, then the current target is the enemy game objects 0. Okay, and the current target state is now locking on, which makes sense. Okay, so it said to you, right, we've got an enemy in here now. Let's change this to locking on. Otherwise, it just says no, the array's still empty. Great, so we've got ourselves an enemy to shoot at, and now we run the lock on method, because that's in the next frame. Actually, it'll run in the next frame, won't it? But in the next frame, it'll say, okay, we found ourselves a target. Let's run the lock on method. And if we wander down here to lock on, I can only tell you that this has taken me an absolute age to code. I will put a link to the package that you guys can download to look at this, because I wouldn't want you to start typing this stuff out. I'll take you through it line by line. Okay. The first line says, well, whereabouts is our current target? Okay, that gets its position, which makes sense. Okay, so this is where we're going to be pointing our turret towards. The current position.y. Now, the reason I set this, okay, so I'm actually changing this position to have the same y value. So in other words, the same height as the turret. The reason I've done that is I don't want the turret angling up or down. Particularly if it gets close, it might start looking a bit weird. So I wanted to keep it flat, if you like, and level. So by setting the position of the target to the same as the position of the turret, then in theory, when it rotates, it's only going to rotate on the. It's only going to look on the X and Z. It's not going to up and down on the Y, if that makes sense. Okay, so then you use this thing. I mean, this is pretty standard stuff. I copied this from the Unity website, the API website, and you can see the way it works is to get a direction. You get your current position, and you take away your position, and that will give you the kind of the direction that this thing needs to face. And then you've got this horror of a line here. Okay, which effectively is a sort of a slurp, if you're aware of that command, which it interpolates a value somewhere between where you are and where you want to be. Okay, I've just realised I think potentially now I just need to have target direction in there. Okay, I've been messing around with this so much. Okay, and then so it's going to go from where we are at the minute, as in which way we're pointing, transform.forward, where it's looking at, and where we want the direction we want it to point. And effectively, it's moving at this speed here. So time.delta time, which you probably remember is the sort of the frame rate, and turret speed, which I've set up here to be 2. All right. You can adjust that as you feel. I think perhaps if you upgrade the turret, it would rotate faster, maybe something like that. I don't know. See how you feel. This little beast of a line here says, well, how much more rotation is there to do? Okay. Again, what I've done effectively is change the careful, the rotation of where we are at the moment. Okay, on the y-axis to the target direction that we need to face. Again on the y-axis. So effectively, how far have we rotated this on the y-axis? How close are we to pointing at the target? All right. And if it's less than 2.5, by the way, Euler angles means the angles that you and I would know between 0 and 360. All right. So this is. I really don't have an answer to you on this, other than just this is taking me an age. Some of you that are skilled in this kind of quaternion stuff will be laughing at me, saying, "No, you idiot, this is easy." But I must say I've spent probably the best part of 2 or 3 hours trying to get this right. So what we're saying is that the remaining rotation, if it's less than 2.5 degrees, then we'll set it to the turret state.engaged, as in we are locked on, we're good to go. All right, and if we just have a look at engaged here, it does 2 things. It says look at target and maybe fire. So let's spin down to look at target, and what this does is it says, right, let's get the position of the target, Let's set its Y position again. So don't rotate on the Y axis. Okay, just turn on the Y axis. And then we'll look at the target position. Alright, maybe fire I haven't written yet. I'm going to add some logic into here to say last time fired, and then perhaps every second it'll fire or something like that, or perhaps it will run every time, but just decrement health at a very slow speed. So let's have a look and see how that looks in Unity. Where are we? There we are. Okay, click on play. I'll zoom out a bit here. I moved it, by the way. I moved it over to here because it was getting tiresome waiting for it to go over to the other end. And you will see that it rotates towards it and then it follows it. And what you may see is when it loses it, it quickly grabs the next one. Okay? And the reason it's doing that is that it's grabbing the... But when we remove an element, what that's effectively saying is it's moving the first element. So the next element, if you like, will be the next one that came into scope. Now you may disagree with that, and what we could potentially do. Let's try coding this now while I'm typing. So this is check for enemies in range thing. Okay, we'll say we'll run a method called int nearest enemy index equals get nearest enemy index. Okay, and then we'll set that, and then obviously we need to write that method here, so we'll quickly do that. No, so it's going to be int get nearest enemy index brackets squiggle. Like so, and then we're going to say for brackets int I equals 0, I is less than excuse me, what is it? It is enemy game objects dot size, no, length, that's count, isn't it? Count semicolon I plus plus. Okay, so this is going to loop through all of the enemies. Okay, so we'll say int distance, nearest distance. We'll just set it to something silly, right? 999, and this needs to be a float as well. Okay, and then we'll say if brackets vector 3 dot distance between transform dot position comma enemy game objects excuse me I dot we need to cast this, so we'll just do game object. Is that going to be kind to me, or do I need to wrap the whole thing in? No, so I need to do this. I need to do another bracket around it. Excuse me if this is confusing. So what I'm doing here is I'm casting this enemy game objects to a game object, because you may recall up here I think we don't set. We should have used a list, and that's my fault. I should have used a list. It would make that a lot more sensible. What I hadn't realised is that list allows generics and array list doesn't. So let's just see if that works now. There we go. Dot transform dot position. Okay. So we're saying if the distance is less than nearest distance, so hang on. So we need to here int nearest enemy index equals 0. Okay. And then we're going to say, so what we're saying here basically is if the distance between our turret and the enemy game object is less than, well, it starts with 999 because I picked a massive figure, so it's always going to come out as true. Let's even go 9999 just to be absolutely sure. And then we'll say nearest enemy index equals I, and nearest distance. Yes, let's do this. Hang on. Float distance to object equals, and let's just store that as a value. Okay, and then if distance to object is less than nearest distance, and then we'll say, the reason I've done that is because I'm going to do it twice. I don't really want to call that vector3.distance twice. So nearest distance equals distance to object. So does that make sense? I hope it does. What we're doing here is we're saying, right, loop through the array, which arguably may only contain one entry, and it's looking at to say, well, what's the distance between the current index of the enemy objects that we're looking at and where we are? Is it closer than any of the other ones we've looked at? If it is, then set that to be the index, and we'll say nearest distance to make sure that that goes down. Otherwise, if you don't reset that, then it's going to effectively pick the last one because it won't be resetting that value. So now we can go up here and we'll say this. Just do that. Change 0. Square brackets. Okay. So now it's going to find the nearest enemy. Now what I'm expecting now is something a bit funkier. When one goes out of range, it's probably going to pick one that's really close to it. So let's just see if this works. First of all, into Unity, it does not all code paths return a value. Ah, yes, we don't return anything. That always helps, doesn't it? So return nearest enemy index. Okay, so even if this is empty, then it's going to return 0. Okay, is that going to be okay? Because we've checked the count here, so it's going to be 1. So it's always going to run this at least once, isn't it? Okay, good. Let's give it a go. Go away. Thank you. Just clear that out and run it again. I'm expecting a slightly different effect now. I'm expecting once one goes out of range, it'll suddenly get kind of spin round to one of the nearer ones. Okay, so it's finding it. I'll just click on machine gun so we can see it going out of range, and it's going to go. See, it's. So this is kind of cool. You can see what it's doing. It's I might just do that so you can see exactly what it's doing. I'll zoom in on it. You see, it's finding the nearer one. I think that's the right logic to adopt, because otherwise it's just going to be rotating to one that's just about to leave as well. So it's picking the nearest one. I like the way that looks. I like the way that turret is behaving itself. Let's just see if there's any null pointer exceptions or horrors like that. Where like I say, where this could go wrong is when they blow up. Effectively, they die. But we haven't set any of the health yet, so we're probably going to have to update this method to be a little bit smarter about how it handles things like the enemy blowing up, basically not being there but not quite out of your array or something like that. We'll have a think about that. So we're done. At least we're done for this part. In the next part we will work on exactly that. We'll work on getting this thing to fire and perhaps do a very simple particle effect. We will work on the enemies decrementing their health so that we can get them to. We'll create a little explosion particle effect and see if we can do that. We're very, very close now, guys. I'm very pleased with that. We also need to think about how we're going to implement that for each of the different turrets. I'm probably going to use maybe. Excuse me, where are we? I'm probably going to make this maybe fire an abstract method, and we'll create this as an abstract class so that depending on the turret type, it would do it differently. Something like that. We'll see how we go. Thank you very much for watching, guys. Apologies that this has taken such a long time to come along. It's because I've struggled with getting this in place because, as you can see, it's quite complex. I've enjoyed doing it. I think we've made really good progress in this one episode. Stay tuned. Like, subscribe, comment. I will do my best to respond as soon as possible to any questions you have, and I look forward to seeing you next time. All the best. Bye bye.